Welcome to Projects from the Bottom Drawer. My name is Brian, and you can find us at wearable.com/projects or bottomdrawerprojects.com. What I have on the bench tonight is the EICO 150 signal tracer again. Last time this was on the bench, we were trying to solve a noise problem, and it turned out to be the transistors, all of them, but primarily the Q3, Q4 pair, which I did replace off camera. I was just pulling them out and putting them back in. There's a post about that on wearable.com, and I will link that in the video description. For Q4, I used an NTE 152 or ECG 152, but pretty much any NPN power transistor that's designed for audio work with a gain of about 100 to 120 will work. Q3 is a 2N3906, a very common PNP transistor. The complementary, well, not the true complementary pair of the NTE 152, but it is a complement to that device being a PNP. And in Q1 and Q2, you can probably use a 2N3904, but I chose to use 2N3319As. And that's just because that's what the internet suggested. So it's like, okay, I'll give it a try and see how it works. They're a little hard to get, but you can find them online. Interestingly enough, when I pulled transistors out, and this is what I removed from the device. Q1, according to the little tag that was in the device, is an SK3124. There's no markings on this device, so who knows what that actually is. And if you're not familiar with that numbering system, that's RCA's old numbering system. RCA, of course, quit making replacement devices some years ago. Q2 was, interestingly, a Motorola HEP726, and that just basically cross-references to a generic AF transistor. And I'm not sure why that's in there, because the tag doesn't talk about that transistor being replaced, but I don't know that EICO would have used a Motorola branded part. They tended to use their own branded parts. Q3 was a EICO part. I have no idea what it is. Doesn't cross-reference, just PNP. And Q4, it looks either like a GE or an RCA part, but it's also marked with an EICO number. No cross-reference, but again, any NPN AF power transistor should work in that position, as long as the gain isn't too crazy and it's not like a specialty device. So while these transistors are still good, as in they do what a transistor is supposed to do, they were very noisy. And when I replaced them, the noise levels in the device dropped from about 0.4 to 0.5 volts peak to peak down to about 0.46 millivolts. 0.046? No, 0.046 volts peak to peak. So let me get my decimals and numbering systems in the correct place so I don't confuse both you and me. So it really reduced by a factor of 10. And there's still a little noise. There's going to be a little noise, and I can see a little bit of 60 hertz hum in there. It's just picking that up from the air. I'm sure the 120 is in there as well, but we're not worried about that because the device works. So what I'm going to do tonight is I'm just going to go back through the transistors, check voltages, and well, that's not terribly exciting. It is necessary for posterity, and hopefully it will help someone else in the future. Those voltages will be recorded, of course, on wearable.com, and there'll be a link to that post in the video description. However, this video will probably lag that post by a substantial margin. So let's go ahead and get some power. We'll check voltages on transistors. We're also going to check the current draw on Q4 by measuring the voltage drop across this resistor here, which is the emitter resistor. The voltage drop there will tell us how much current that device is consuming. And I'd also like to try and dial back the meter sensitivity some, that is, increase the meter sensitivity, because you really have to drive this thing hard in order to get meter deflection, and that's the same with eye tubes. I don't know if that's the way their circuits are designed, or they expected you to have that farther away from you on the bench, but I want a little more meter deflection at lower volumes, because at higher volumes it's just too much. For that, I have a 100K pot, and we'll just parallel that with the 10K input resistor, and then just slowly turn it down and see how it reacts. So let's get the device on. We check the voltages with no signal input, gain all the way down, and I cannot hear anything sitting here where I am. I'm going to put the microphone right up next to the speaker. You probably will hear just a little bit of hiss, a little bit of crackle. And I have to put my ear right down to that to hear anything at all over just even the whisper fans here in this room. So I would say we solved the noise problem. We could probably get rid of more of that noise by replacing all of these carbon comp resistors. Is it worth the time to do that? I don't know. I would say no. But, maybe later on we'll do that, since this is a single-sided board, and this would be pretty easy to get all of those out of there and replace them. All right, so I have my ground. Let's see. And what I'm going to do is I'm just going to go through all of the transistors. Write the pins down. I'll read the voltage off, and of course, as I said, that will be posted on wearboard.com and linked in the video description. And I'll do a comparison of old versus new. So let's get started here. Let's see, Q1 emitter, negative 739 millivolts. Base, and we're not on the base, negative 0.737 millivolts, so that transistor is probably not biased on. And collector is 0. So Q2 emitter, negative 4.557, base, negative 4.554. As I recall, these were all over the place with the old transistors. Yes, pop, pop. And let's see, a bit of flux there I need to clean off. And collector is negative 3.847. Q3 emitter, negative 1.250, base, negative 1.860. And collector, let's see, can we get in there without hitting other stuff? Negative 16.16. Now, as I recall, that's closer to what this actually should be. I can't remember, but I know it was supposed to be fairly high. So let's go to the underside of the chassis. And as you can see, the transistor is now insulated better with leads. It has wire instead of just things flying around in the air. So we'll check here at this new tie point. The collector is negative 1.308. Let's see, let me get my cheat sheet out here. That should be lower than that too, but I believe. Let's see, pin A is the base, which is right here. Negative 16.13, which makes sense because it's directly connected to the collector of Q3. So we'll just call that 1616, same as the collector. And the last pin is negative 16.74. Now the collector is supposed to be 0, so there's still current being consumed there by that transistor. I honestly don't know why it's not doing anything, but yeah, whatever. Now let's check the current draw. I mean, we already know it pretty much, but so the voltage drop across the emitter resistor is 1.096 volts. So that's 109 milliamps, which is substantially lower than what it was before. But again, according to the manual, there shouldn't be any current consumed in this circuit at this time, which to me doesn't make any sense because a transistor is going to consume current. Even when it's just sitting there, a Class A amplifier is biased on at all times because it's biased in the middle of its output because it has to swing high and low. And of course, if you biased it down at 0, like half of a push-pull output, you'd lose half of your sine wave or whatever you're trying to put through it. So right now these values don't mean a whole lot to us, and I'll set those aside and process those later. But what I am going to do here is turn this off. And please stand by while I set up an audio source for this, so we can adjust that meter. And I'm going to just use the, let's see here, come on out, don't be shy. I'm going to use the Trexter radio that was so kindly provided to me as a review sample. These are awesome little kits. If you'd like to build one, you can find them on eBay, Trexter. I'll have to look it up, but I'll link his page in the description. He solders the IC on for you, but they run on 3 volts, so you can pretty much run them on anything. They just require a power, ground, antenna, and you have radio. So they'd be great to just shove in a drawer, because you can power them off of a couple batteries whenever you need it. And that was kind of his intended purpose, is these are designed for an emergency type situation where you may not have anything else, but you can possibly get hold of just some batteries to wire something up. And one of the things I'd like to do with this is eventually try and make a bleach battery out of copper, aluminum, and bleach, and see if we can run it off of that. So simulate a true emergency procedure. So let's see, let's get power supply up here. Okay, looks like we got 3 volts. And one of the things I did check on this is the voltage, or the current, the voltage draw, yeah. Don't be an idiot there. The current draw on this is about 35 milliamps. So on a set of D batteries, you should get a substantial amount of time to play. So let's get this connected here. All right, let's move that under so it doesn't go around. I really need to get an antenna in here that I can leave permanently mounted. But shoulda, coulda, woulda. We'll do that later. All right, so let's get an antenna. I'll just drape that over here to give us something. And let's get a ground. Now I'm using FM, and you don't really need a ground for that, but I'm going to earth it anyway, just because. Let's see, let's get that in the frame. And let's turn this around so we can see what's going on there. Okay, let's get some power. Okay, looks like we got a station there. Well, that's not very loud, is it? And it's not very loud because someone whom I shall not name did not connect the ground. And it's very difficult to get a return path when you don't have a ground. So let's get a ground here. And that is just the little ring here on this. And let's actually do this right. Let's use the correct kind of connector for the input on this thing. That is still not very loud at all. So, is this thing not capable of driving that? Or do we need to put that in on the... Let's see here. Maybe we need to put that in on the RF side. All right, so let's get put these into here. This weird little adapter thingy that I've got with another piece of equipment. All right. Interesting. So, does this thing not... stand by.
for you, based on individual members' experiences. Results may vary.
Wendy's new Biggie Deals lets you choose whatever you're in the mood for.
All right, so this thing. Yeah, I can't really say what's going on here, so let's get some audio coming in here. I don't know, maybe those transistors just aren't working. Maybe I have to let's see, let's get rid of that. Well, there may be some more troubleshooting necessary to make this thing work properly. And I am getting nothing out of this thing. What's going on here? So maybe these transistors don't work. Interesting. All right, well, let me clean up a little here. I should leave that on. Did I not connect something? All right, let's just move the radio out of the way. I know the radio works because you can hear it playing here across this little Rat Shack speaker that I have on my bench. We'll put that back up here. Let's turn the power off to the radio. Antenna and ground, yes, that's correct. +3 and -3, yeah. Or minus rather. Let's see, let's get these connectors out of the way. Alright, let's put these guys here. I'm just moving these out of the way for the time being. Let's see. So let's bring you around. Okay, yeah, that shouldn't be problematic. Let's see, oscilloscope probe. Where did you go? There you are. Let's get the scope on here. Bring the oscilloscope back. And let's see what kind of signal we have present here on the speaker. Alright, let's get, where's my jumper to jumper at in here? Who knows in this mess? And let's just go right in on the terminals. That way we're not worried about anything here. I mean, there is nothing. There's a little bit, but I mean, that thing should be just as, that thing should be ear splitting. There should be a lot more volume than that. And there should be something. And does this probe not work with this scope? Yeah, let's get a different probe here. We should be seeing something there. If I can get it off of there. Oh man, come on. Man, there we go. Let's put you aside for now. Let's get this other probe out. And there we go. Wow. Distortion. So obviously something isn't working here. So who isn't amplifying correctly? So let's see, Q2 on the bass. Interesting. Is there anything? I'm on the collector here. I can get on without hitting other stuff. Okay, the scope can't find anything there. So let's just look here at the input real quick and see what we've got. Okay, we've got a little bit of input, about 0.8 volts peak to peak. Well, no, about 1.56 volts peak to peak. That should be more than enough to drive this thing hard. But the fact that something is screwbally here, so let's see. Nothing there. Nothing there. Let's get a ground back where we had it. It's hard to get in here. And there is nothing there. Actually, let's take that off. Let's see. Let's get a, it's getting warm. I mean, so it's doing something. So let's see. There's our output's lower than our input, which is not an amplifier. Let's see. Nothing there, which probably shouldn't be. I think that's ground. And nothing. So the device is not amplifying before The final drive stage. How interesting. Maybe the 2N3906 isn't a good amplifier choice for this thing. Well, crap. I was hoping we could tidy this thing up. Yeah, I mean, that's distorted mess right there. So can we get... No, I can't get anything other than that distorted crap. So where is this thing coming in at? All right, let's turn that down. Let's see, do I have... I don't know if I printed the schematic out for this guy or not. Looks like I did, yes. So let me get that out here. And the schematic is available on Internet Archive for this thing if you'd like to pull your own copy. Let's see. So, injecting right into the base of Q2 through the gain control and a blocking capacitor. So let's do that ourselves. So let's see, here's the gain control. Which one of those is ground? Let me see here, where's the power switch? So let's turn that off while we're working with that. So let's see, audio goes to 6, comes into 5, and then immediately goes to Q2. Interesting. So R6, 5K, let me see here real quick. So you jumper from there to there. So it comes out of the gain control into the blocking capacitor. So let's put that right on the output of the gain control. The center tap of the gain control. Alright, what the heck? So I mean, that's what I would expect with this input. You should be able to just drive this thing until your ears hurt. So what's going on here? So okay, I mean it would still potentially change the gain because I've got it on the center. Let's see here. I don't know if you can see this well, but right here is the gain. And if I put that on the center tap of the potentiometer, I can still vary it because I'm moving that between ground and not ground. So why? I mean, there's not a whole lot there other than this capacitor and this switch. Interesting, interesting, interesting. All right, well, unfortunately I need to put this in a better position for me to work on it for now. As soon as I figure out what I did with my stand, there it is. So let's turn this down. Let's see if we can bring this in a little better for you guys. Stand by, please. Let's see, move the camera. All right, that's a little better, I guess. So here's our, yeah, let me stick my fingers in there with a live circuit, dum-dum. Here is our gain pot, which of course we've also got the power switch on the back of it. And I might take that off and unwrap that. That's nasty looking. All the way over to there. Move that down onto the chassis. Yeah, whatever, we'll do that later, but so we come over to the switch. So this yellow wire here is our input from the switch. So let's check. My meter is going to need recharged soon. Oh, messy, messy wires. So what would have happened here that maybe Q1 doesn't like being the same as Q2? I don't know. So let's put the scope away. Let's get the audio source out of the way here. And untangle the wire in the process. So earlier today, after probably nearly 30 years, I had to put a new tip on my main iron. You know, I have to say that that's been a pretty good tip. It was finally starting to wear and kind of buckle over and giving me like a little curl at the end. So it's like, yep, you need to go there. So let's see, I want to do this. I wonder if Q1 is in properly. I mean, it should be. And we'll check that in a minute. First of all, let's just check to make sure that the switch has continuity. So I want to go from the switch itself, and we'll put this on resistance. So let's turn this off. Okay, so our audio input. So we should have continuity. See, is that our audio? I mean, that is our audio. So let's go from here to here. Just going to go back and start checking all connections. And I might have to replace this piece of weird wire eventually. Okay, it's 0 ohms across this piece of gray wire. So now we've got 0 to there. However, we don't have anything to the potentiometer. And as you saw on the schematic, we should have 0. So, let's see. Are we on? Okay, that is speaker. Yeah, I mean, I can see the switch wafer And that's kind of dirty there, but not terribly. I'm going to hit this with deoxit. It did clean it up quite a bit, but I might have to get in there and really scrub it. Let me just hit that wafer real quick. Let's see, we've got, where are we going here? Okay, so that's RF, and this is audio. Well, I don't understand here because, excuse me, because I have this in the audio position, and the audio lead is just going nowhere. I mean, if I put this over here, I can get to this input, that's 0, but there's literally no connection being made to the switch. So let me think about this for a minute. Now if I turn it to RF, RF makes a connection between this purple wire, which goes to the pot, and the audio lead. Let's see, do we have continuity. And that goes to ground. What? I mean, yeah, literally when it's in the RF position, it is shunting. Okay, that makes sense. It's shunting the audio input to ground because you don't want, well, that doesn't make any sense either. So you've got, so where would this have to make connection to? I'm beginning to wonder if this switch is wired correctly. So 7, I might have to pull the manual and look at the switch diagram here. Because in this position, let's see. In this position, audio should not even be, let's see, in this position, audio is not connected. Okay, that makes sense. It's audio is shunted directly to ground. You don't want that either. In this position, audio goes nowhere, and that's the audio position. Oh boy. What is going on here? Did this thing ever work? I'm beginning to wonder what's going on here. So technically this, the speaker position is now connecting the audio. So yeah, it's almost like they wired it backwards. All right, well let's get some audio back here, and we'll try it this way. Let's get a ground. Let's get this off of there. Let's get some audio back. Turn. Nothing. So is there something going on top of this thing that I can't see? So what is that yellow wire going to? So the other side of the pot goes to C3. Is that good? And that goes to, where does the center go? The center goes to a capacitor. All right, one moment, please. Okay, so Q2. Let's turn this off real quick. So 5, yeah, I'm going to have to pull the manual for this and see what the actual switch numbering is. But let's try and figure this out real quick. So one of these pins should go to ground, and that is 7. So what are these doing? Those are, yeah, it looks like there are two sets of wafers here. All right, so pin 6 and pin 4 are not connected to anything. So 1, 2, 3, 4, 5. No. 1, 2, 3. 5, 6. This isn't making a whole lot of sense here. But I mean, literally, when the audio, when this thing is in the audio position, there is literally just nothing connecting this contact to anything. So I bet if we put this in on this yellow lead in the audio position, we'll probably get something. And this is one of the things I've always hated about electronics like this, is just these switches. Sometimes they just don't make any sense at all. And you're relying on someone else to have properly wired it. And again, was this thing even wired correctly when it was new? Now that's exactly what I would expect. I mean, that's exceedingly loud right there to me. But if we put that in on the input of the device, I mean, it literally doesn't go anywhere. It can't. You can't get any audio out of it. What is going on here? Well, in any event, let's turn the scope off because the battery is just about dead. I need a new battery for this guy. Just an 18620, I believe, is the type. It's just that round lithium ion you see everywhere, and it's just shot. I've used that scope meter, that little Zotec device. I mean, I can't beat this thing for what it does. It's just great, especially for $45. All right, so let's get rid of that noise. And then we'll go back to the original test. Okay, let's see, let's turn the tracer off so we don't sit there and bake tubes and heat. Okay, so once more, let's bring that. No, don't do that, silly thing. Let's move the camera back to where everybody can see what's going on here. Let me make sure I have everybody in frame. And I do. Good, good. Okay, we got a ground again. Let's see all the leads I put down here. All right, let's get some power supply back here. Let's see, +3. I probably should mention to the creator of this board. This says +3 and -3. That should be like +3 and 0, because he gives you a 3-volt battery pack with that. Just semantics, but it might help someone who doesn't have all of the knowledge that we have. Okay, so these are not going to do what we want for this particular point in the test. Although this one will, because we need a ground. So let's get our ground back here on the output. And let's see, let's get a audio here. And the only reason I've got this wire here is because I don't have any headphone plugs anymore. It does come with a crystal set headphone. So, you can use that or modify it. I'll probably eventually take this off and just put a couple of leads on, or let's see if I can shove a one of these screw connectors in there. All right, since we need a decent antenna, let's get a little bit longer here. We use the audio leads we were using from the signal source a few minutes ago. All right, let's get some power. Get a station tuned in here. And that's exactly what I would expect. See, can we get a commercial?
All directions as we near the end of rush hour. I-70 westbound also improving off of 310 coming over through Licking County. We had a crash scene blocking a left lane earlier. There's still some delay for 23 northbound getting up to 750. I'm Johnny Hill for the Total Traffic Center.
This report is sponsored by Hondros College of Nursing.
If you've been thinking of a career in nursing, get to Hondros. We've trained and graduated more licensed nurses than any other school in Ohio over the last 4 years. So get in, get ready, and get working. Visit start.hondros.edu today.
Your next.
All right, there's your commercial. And as you heard, as I turned it up a little bit higher than I should have, this thing will blast you out. And that's exactly what should be going on. But it isn't, because this is wired weird. Now, this to me does not look original, this piece of gray wire. In fact, I mean, that looks like somebody just took a piece of whatever they had laying around the shop and put it in. So maybe this unit was modified for something else. I don't know. The person that I got it from simply told me that he didn't really have much information about it. He just knew that the gentleman that had it in his estate liked to buy broken and modified things. So who knows what was done to this unit. I mean, it obviously had a lot of work over the years, and it's still going to need some work, especially here in the function switch. I need to pull the manual and actually look at their picture and say yay or nay, this is not working, or it is working. And if there's, I mean, there has to be something going on here, because I mean, the switch does not look modified. All of the tines are there that you would put wire into, or terminals, I guess. These aren't really tines. But it's just that when it's in the position that it wants audio for, there's just no connection to the audio input. I mean, that audio input, they've actually got the, no, they don't. So could we do that? Let's just check something here real quick. That's making a connection to the RF circuit. Can I get on there? No, unfortunately I can't. Interesting. So there's definitely something else going on here that I can't see without pulling the manual. But for now, that's all I have. Again, if you'd like to build your own little radio kit, I will post a link to that in the video. Awesome little kit. And I do have another one that I'm going to build. This is the 4-band unit. I also have the 6-band, which I'm going to build, and I have the crystal radio unit, which I've already built. Super cool. I mean, and I think I really do support, small creators like this that build things that are cheap, under 30 bucks, and aim towards someone that's a hobbyist, or someone that just, might want to build something, see it work, and have something useful. Because a radio, radio has faded some over the years, sure, but there's still plenty to listen to, plenty to do with radio, and everybody needs at least one radio in their house that they can use just in case they need it. So thank you for joining me tonight. Hopefully we can figure out what's going on with this thing soon, because I'd like to see it work and get it off the bench. And you can find this device and many others I've worked with at wearmore.com/projects.